What is up, car and craft fans? I'm very happy to say that the prototype Auto CC, as I've been calling it, the ESP32 ESP-NOW powered communication system I've designed for cars, is now available online, and it's up on Github, and you can go and take a look at it and potentially use it in your own systems. But it is right now very much in an alpha stage prototype, so there's still a lot to do on it. But what I thought I would do in this video is show you how you would take your application and implement the code in it so that it can communicate with a server in this standard that I have defined. And you'll see that I've tried to make it really, really easy. So no matter what level of kind of coding you're at with C++ and Arduino code, you should be able to get this running and be able to control your Arduino application from another ESP32 that's running the server code. Now at this point, like I say, it is alpha stage, so there are a couple of quite large caveats. One, only button types, so an on-off switch, and range type, so between X and Y, are supported at the moment. I will be implementing colors and multi-choice and text input. We'll be implementing all of those over the next week or two. Secondly, I haven't built a UI proper for it yet. So if you've seen some of my previous videos, we're just going to look at the one that prints out menu options in a serial monitor within the Arduino IDE. But screens and things for it are on the way, and I'm just waiting for them to arrive. And then I will be building a full interface for it in Preact, which will then serve the interface both on a screen but also to a web server so you can access it from your phone. Thirdly, being an alpha, it's probably got some bugs in it. I've tried as much as possible to test it as I go and make it as robust as possible, but there might be things that are issues with it. If so, feel free to report them on the GitHub or pop a comment down below and I'll take a look at it, because it's not going to be perfect straight out of the box. But let me show you what is up on GitHub. If we just jump over, we've got this Valentine Auto's Auto CC. The URL is in the description if you want it. And like I say, if you're not aware of what we've been making, it's a wireless, self-constructing ESP-NOW powered communication standard to link and control ESP32 Tinker projects in a car. But we'll likely have applications outside of that as well. The idea of it is that you can create devices that have a standardized system of defining how your options for those things work, and the server will automatically be able to build itself based on the devices that attach to it. There are obviously other systems that exist for Internet of Things communications, such as MQTT, which is like a standard for it. But the big problem with that, not really a problem, but its limitation, is that you have to build your devices, but you also have to build your subscriber, and you have to tell the subscriber what it's listening to and build your UI based on your devices. Where this is different is the UI will build itself automatically based on the devices. That's what I've tried to do here that is a little bit different. Now, there may be an opportunity to integrate the two so that it uses the MQTT standard for communication, but uses this kind of library to automatically build that on the fly. That's a rabbit hole I'm just at the very, very edge of potentially going down. So yes, I'm aware of those technologies, and yes, I'm aware it's probably a good idea to maybe use those standards as they are well defined everywhere. But it's something that I've just not got to yet. But like I say, we're in alpha. So in the GitHub, you have the code for three different things really. We've got the Auto CC, which is, as I said, I've called it Auto CC. It's Automotive Control Center, and it's a control center that automatically generates itself, so works on two levels. And Auto CC is just the common stuff. It's got a bunch of reusable functions and things in there, which we'll look at in a minute. And then we've got the client and the server code. The idea is that you don't require all the client code on the server and you don't require all the server code on the client, so let's just keep them separate. When we scroll down, we'll see basically the functions and stuff that you will be required to use this. There's not very many at all. There's a few shorthand things. So I use a shorthand print function. It just means that I can use this debugging flag, which I'll show you in a bit, and turn all the serials on and off for error handling. Just means I can keep my serial line a little bit cleaner. And then an isValid So if I pass it one of my options with a new value, it will verify that that value is correct based on the type it is. If it's a button type or a range type or a color type or whatever it is, that's the thing that is limited currently to only switch type and to a range type. The others will come in time. And then this is just showing some of the stuff. So for example, if we're on a server, we can access, when we have the library plugged in, a number of menu options, which will tell us how many items we're controlling over all of the devices. A request list, we'll get to that, and the menu items themselves. So this is an array, this .menu items, we can loop through and pull out all of the information that we need to build a UI. And then in the methods, we've got just a couple, a begin, which we need to pass it, clients, and the number of devices. The set value, where we pass it a unique ID, we'll get to how that works, and a new value, and reset clients. So if we've had a screen where we can change the attached clients, we can do a save and it'll just destroy all the menu and then reboot everything. It's basically a reboot. And then the client really has two, begin and get value. That's all you're going to need. So setting it up on a client and then getting a value that associates with an option so you can do things with it. It may all seem a little confusing out of context. So what I'm going to do is build an example with you now of updating a very simple application to use this as a client and show you how it then interacts with a server and show you how easy it's going to be. It's going to take us like 10 minutes. So if I bring some code in, we've got the server here, which we're not going to worry about too much, but then a very, very simple sketch that I've just written, which basically defines some NeoPixel strips. So over here, we've got two ESP32s here that they look like they're interconnected, but this is just a power source that splits out the 5 volts to everything. So we've got this NeoPixel strip that is connected to this ESP32, then this set to this one, and each one of them's got a button, and they're both in all the same pins. So when you press this button and hold it in, that set of light comes on, and when you press that light set comes on. And that's it. That's all this application does. So we just define everything. We've got a little bit of state management. We set up the NeoPixels. We've got a function that does the color setting. We've got 2 display modes, on and off. We set up whatever we need at the start, and then we've got a thing that listens to the button press, changes the state, changes the state, and sets the correct mode. And that's it. It's really, really simple. So what we're going to do is integrate this into my system, and then you can see how the server can override your ability to do that. So basically turn this button on and off from a server dynamically. A good way to demonstrate that is if we look at the server currently, it's running the wrong port, but if we plug the server in, because it's currently not in, and then we change the port monitoring to 10. There we go. So as it booted up, we can see no current online clients, all available options requested, no options menus available, because it's gone through its list, even though we've currently defined lights A and lights B with their correct MAC addresses here. Even though it knows these devices exist, they're not responding with anything because they don't have any of the code on to do it. So what we want it to do is be able to ping them and go, what can you do? And this is how we set up these lights to include the code that will power all this up. So first we just need to include the package. So we're going to include, and being as we're on a client, we want auto cc client.h. So obviously, to get this to work, you would have had to have downloaded the package and put it into your Arduino libraries. So here, AutoCC, and within here you should have all of those files that you require. And as long as they're in there, that auto CCH include will work fine. Then we need to start it up. So, to use that code. So just before the NeoPixels here, we're going to go auto CC client, and then we're going to call it CC client. So now it's pulled in all the stuff related to the client and initialized it as CC client. Like I said, in the client methods, we've got this .begin, which is what we're going to need to use here. So if we just copy that .begin and we go down to our setup, we can do CC client .begin, and then we need these things. Now these structures, if you ever want to look at what these structures look like, if you go into the auto CCH file, we have these structures. Now the demos do have these written out in the examples in the where the code actually goes, so it makes it a little bit easier. But really, we're doing these ones: structure setup here and structure peer. So what we need to do is have a server information, and options information, and the number of options. So server is basically saying what is the address of the server, of the MAC address of the server. Options are what options are available. So what things are we going to be turning on and off, or setting the range of, or setting the color of, or whatever it might be. And the number of options. We just need to pass that because there's a quirk with C++ is if you pass through the number of options as an array and then try to get that number of options, it just doesn't work because of pointed arrays. And so we just make our lives easier and just pass through that number of options. So we need to set up these three things. Let's do it at the top here. So we're going to start with server. And server has a type of a structure peer. And in the example, you'll see how to set that up. But all we need to do is basically give it a name. So it's server, and then give it its MAC address. And the MAC address for my server happens to be that. So this format is just the format that you'll need to set it up. So that's our server set up. So that server variable is now going to pass into that begin function and satisfy that requirement. Then we have options. Options is again an array. We don't know how long it's going to be at this point, and it needs to be the type of structure options setup. It's got a weird little name compared to some of the other ones because we actually pull this setup apart and build it into a larger options structure, but we do that behind the scenes. You don't actually need to set up all of the flags and the unique IDs and all that stuff, so it's a separator. So yeah, it's got a slightly more complex name, but we set up that, and again it's a array, and in here there are 6 options that we need to set up. First one is its unique ID. So this one we can just call button state, and then we'll create a ID for it here, and it needs to be a string, so we'll call it button state, and that needs to be a unique ID. So if you were going to do a second one over here, you could call it button2state, but you would give it a name that is a unique identifier. That's just required for some of the passing of checking of stuff that we do later. Then we give that a label. So the label is what it will show up as on the server. So we're going to call this button light. Then what type it is. So this one's going to be a type switch. Again, if we were to look in the AutoCC file at the very top, we've got type switch and type range. As I expand this out, that type options will get larger, but currently type switch and type range are available. Its minimum value, so for a switch will be 0, and its maximum value will be 1, and what its default value is. So we can just use off because there are shorthands again in here for on, off, online, offline. So we can just use off. And that is that button setup. One thing to note is because it is a switch type, the min and the max of the range don't really do anything, but I think just setting them to 0 and 1, A, makes it more readable, and B is just sensible. Now, if I had a more complex program that had lots of buttons and lots of inputs, what we would do is just expand out this list with as many as we need. So these could be, you know, button state 2, and that would be button 2 light, which is a switch that starts in the same way, and then there might have a range input here that goes from 0 to 100, and it starts with a value of 50, and that could be a range state. So you get the idea. You just basically build up your options here based on what you want to be able to control from the server. For this instance, we've only got the one button and it's a type switch. So that will fulfill the options requirement in the begin function. Then there's finally number of options. You could just do int num of options equals 1 and hard code it. It would be absolutely fine to do that. Hell, if you wanted and you knew you're never going to change it, you could just stick 1 in here. Really, the best way to do this is just to do size of options divided by size of options 0. Then as we change this, that number of options will automatically update itself. So that's the best way of doing this, and it's super simple. So you can just set it and forget it. So that satisfies the final one of the criteria for the begin, the number of options. So now server, options, and number of options have all been defined, and they'll all be passed through at the begin, which means the server will be able to control them. What we need to do now is ensure that the server is actually able to kind of overwrite those settings. And at the moment, it's just a switch type. So we want to be able to say the button press does nothing. We're basically deactivating it. In the future, there might be a way of saying always have it on, always have it off. You know, that's going to be a multiple choice, which we haven't got to yet. But for now, we can say deactivate that on state. So we need to wrap the code where it's switching it on to say actually only do this if the server hasn't deactivated it. And there are multiple places we could do that. We could do it on the on mode. I think probably the best place is to let the states actually change, and we'll do it in the on mode. So around this we'll do if whatever, then do the set neopixel. Otherwise, we'll just say that lights are blocked. So if the server allows it, we'll put that code in now, then do the set neopixel color to red as normal. Otherwise, we've blocked the lights, so that operation doesn't happen. And the code for this is really simple. It's just going to be cc client again dot get value, and we need to get the value based on the ID. So like I said earlier, just setting these IDs at the top makes life a little bit easier. So define button state. So this is the ID I'm talking about. So we can use button state. So if get value of button state is equal to 1, then lights on. Otherwise, lights off. And that should do everything. Now, what it's saying is that it checks the value that the server has got saved against this, sees if it's 1, and if so, lets the lights turn on. Otherwise, it says that they're blocked. Let's just try verifying that just to make sure I haven't missed anything. But really, that's as complex as it is to set it up. It's taken us 10 minutes? Easy. Oh, I've made a mistake. Error. Where's my error? Oh. Whoops. Semicolons are the bane of every programmer ever, especially in an IDE that doesn't automatically check for them. So that's finished compiling, and just currently, just to show everything, the code still works fine, and that goes on and off. And the server has got no menu options, and I'm just going to reboot the server with that one. And we'll see after the slight delay, it's trying to attach to those two devices, and it's failing because they don't have the code. I'm going to upload this to the one that's plugged in. So this one to start with. When we've got through this, I'll explain what all these kind of like unique ID things are all going on and how this works in a little bit more detail. Because I think I made some changes from last time, and I think it's pretty clever now. Right, so this one is all on. I'm just going to reboot it. So now that it's rebooted, the server is registered, loading button light, saved value is 0 because we've never changed anything. It's just got the saved value as off. Basically, it's got this thing in it that goes, do we have a memory value for button state? If not, make the memory value whatever the default is. So this is just the default setup. Once we've started setting it from the server, that default state no longer applies because we use the memory value. We don't use EEPROM anymore. We're using NVS. So we're just going straight to the source. So the lights are off. And again, lights are blocked currently because it's on off. So if I reboot my server, well, you can see though that works though. Lights blocked because it's getting that memory value. If we reboot the server, let's clear this. First one has failed, second one, success. So it's tried to connect to the second device, and it's seen that it actually has what it needs. It's done its bunch of requests, and it's got the one menu option. So we've got this button light, which is what we called it over here, button light. It's a type 0, and its current value is 0. And if these two buttons here just loop through the server, this would loop through the whole list of menu items, but at the moment there's only one menu item. Then this one just resets it. So at the moment, only the switch type is really working here. So if we press it, it goes through its list of stuff that it does, but it sets that to 1. And over here, we can see new value set to 1. So this suddenly works again. That's on, and press this one, and it turns it off. It's blocked. Unblock it. And it's basically instant. ESP-NOW, which is what it uses in the background, is very, very quick. And the setting and the changing of everything here is great. So what I can do is just unplug this and plug it into the second set of lights. I'm just going to give this a slightly different name. So let's just call it button light B, and that will be sufficient for seeing them differently in the menu. Just going to upload that code to there. This one has power though by this 5 volts, so I'm going to have to upload this and then put the cable back in here just to ensure that this one has power. The convoluted wiring setups of testing multiple ESP devices. This one will probably initialize off as well in the same way that the other one did. Yeah, error finding saved value, which is what we'd expect because it's not booted up properly before. You have to do, after you've uploaded the code, you have to do a reset and then it will initialize all the stuff. There you go. So I'm just going to unplug this one and plug it back in over here. But this one is probably off now. Yeah, so that button no longer works. This one's server is currently only connected to the one device. So if I reboot the server, it should this time connect to both devices. There we go. So it connected to the first one, it got the structures from it, it's pulled its one option, success, then it went on to the next one and it pulled its one option. So there now are 2 available. So there's, if we press this button here to switch through the values, button light and button light B. So button light B is currently off. We turn that it turns to on. So that'll activate this. And the other thing that's like quite neat about this is if I kill all the power to here, so currently it's on, let me just turn it off. It's off. If we kill the power to it, give it a second, start it back up again, it's off. If I turn it back on, oh, it's going to have an error because the IDs are now out of sync. So if a device restarts, your server needs to restart, else it can't reconnect to it because of a thing that I've done with IDs, which is real smart. Yeah, so as you can see now, the server successfully boots up and it has both the devices connected to it, and it can just loop through all of the options and change them as required. So that's how easy it is to set up a client on this system. You basically just give it its initial values, so the server that it's going to attach to, the options in the format that you want, and the number of options. And then you wrap your commands like this in a checker based on what it might be. So, you know, it might be, is it within a certain range, or whatever it might be. You know, sometimes it's not going to be a checker like this. It might be a case of these colors here are being pulled in from the back end. So we use the server to change the color, and then this red might be cc client dot get value of you know, color red, and so it will just pull that color based on if color red up here was set as one of your options. So you don't even necessarily have to be doing anything in this code to set the color red. If you wanted to change that RGB, you'd come down here and we'd go, okay, well, we've got red, green, and blue. So we've got color red, color green, and color blue. We'll just do one of them. And we'll call that color red. It'll be a type color, which we haven't defined yet, but will be a range from 0 to 255. But we could do it as just a range type from 255. It's got a default maybe of 100. And that's all we do. And then now the server knows, okay, well, this is a thing that can be set and changed. So when we you know, load it up into the server, we'll be able to change that value. And then in here, we just have to ingest it. So that would be like that, color red. So get that value based on color red. And all the checks behind it, and then this one, color green and color blue. And then all the checks behind the scene to make sure that they're valid colors and all the setting and all that kind of stuff is all just handled by the library. All you've got to do is just ingest it from the colors from the library, as opposed to, you know, writing them up in this code. So that's basically the process behind it. You set the options that the library is going to use, and then you pull out those library options, and then the server can do all the communication and the setting of all of those things. That's it. So if you wanted to have a play with this and try implementing this into your own system, that process that we've just gone through shows how simple it is to do it. One of the caveats, like I say, is at the moment the server is very, very crude. It works on a serial line and it loops through one button at a time. I do have I decided to use a 4-inch LCD screen, which I'm going to, with a capacitive touchscreen, which I'm going to build like I say, a UI for. That will happen over the next week or so. The screen is due to arrive, I think, on the 26th. So once that's arrived, I'll start creating a UI for this, and then it will start to probably explode from there as the different elements come in. Also, I am going to build out the server part of it so that when you start it up, it boots up with a web server that you can connect to with your phone browser by just going to an IP address, and all of the options will be in there. I'm going to build that in Preact, which is like a compact version of React. So again, that will build out very, very quickly. And I think a lot of people may just use that. You might not necessarily want a UI in your car. You just want the ESP32 hidden away somewhere, and you can just access it through your phone. You will be able to do that, but we will also have optional like screen UIs for people who want to implement them somewhere in their car or wherever it is you might want to use this thing. So that's how you implement it. Hopefully you can see that's easy enough. If you think it could be easier in some way, please let me know and I'll change it, but I don't think I can make it any simpler than that really. I'm just going to spend 5 minutes for those of you who are interested in like the how it works, showing what some of all this like mass of startup messages means, because I think it's quite interesting the way that I decided to approach it in the end and why I built this custom solution as opposed to using an off-the-shelf one. So let's just spend a couple of minutes looking at that. I'll just bring in three windows with 6 files in. The common, the server, and the client. Right. So common stuff, like I was saying earlier, is exactly that. It's just things that can be reused between both the client and the server, and things like the structures that are commonly reused. So we've got the structure of a peer, which is used the same with both a client and a server. That's probably something I should have mentioned earlier. If you're going to create a server which attaches to it, you need to ensure that your server has the MAC address of your client's set up here. That's all you'll need to change. Everything else should automatically sort itself out. So if you're going to set up a server connection, you just need to make sure you've got your MAC address of your devices and put that in there. Otherwise, like I say, the common stuff is all in here. So there are like a list of structures that define communication standards back and forth. I did have, I think, 5 different communication standards, and I've reduced that to 2. Sending an option from a client to a server and sending a request, and the request types and the value. So I did have request, response, message, option, and set value. They're now, like most of them, have been amalgamated into just the request, and it's just a bit more functional. And then we have some common functions that I've created, like create a unique ID, which I'll talk about in a sec. This stuff, the register peers, initialize ESP-NOW and connect to Wi-Fi, are common ways that it initializes ESP-NOW, and it's just the stuff you need to do for ESP-NOW, so I just made them available. There are 2 versions of find option from unique ID, depending on the structure format, where we can just pass it an option and pass it a unique ID, and we'll get back the option. Again, we'll get to that. Then the valid value checkers, so we can pass its valid value and pass it an option and its new value, and it'll say whether or not it is valid. And then send request, which sends a request from a device to an attached device. So when we look in here, we've got, like I said, I have some shorthands for print, so I just use print instead of serial.println throughout, and it means I can use this debugging flag, which is in here at the top, debugging true or false, and it basically turns all the serial printing on and off and makes life a bit easier for doing that, rather than having to have this if debugging all the way through the code, which was really painful. And then these are like this connect to Wi-Fi. This is a standard thing you would do for ESP-NOW. Same with the initialization of ESP-NOW. Generate unique ID does exactly what you would think it does. It creates a new unique ID, which happens every millisecond. It's why when a device reboots, the server has to reboot. But it also, I think, is probably the cleverest thing about all of this, and we'll see why we've done that in a moment. Register peer is an ESP-NOW thing we don't need to worry about too much. Finding the options basically just goes through the list of the options that we've created and tries to see if we have one based on a unique ID that has been passed to it. And then the valid value checkers, they're all pretty simple. And then the send request is just an ESP-NOW function that just sends the request out to, you define the MAC address and the request type and what the request is, and you send it out, and that's pretty simple. So when we're talking about the client and the server, I think it's probably best to get like an overarching view of what happens. And really, we saw it when the server was booting up, that you get this initialization and it tests the awake state. So what it does is it goes into each one of these things that it thinks is a device online, and it tries sending a test packet to it. And it's just a request type that says, are you awake? And it waits for a timeout, so there's a timeout in there that runs, and it waits up to 2 seconds. and then it waits to see if it replies saying, yes, I am awake. If it doesn't reply within the timeout, it skips it and goes, okay, well, I don't believe that this device is online. So it does nothing with it. So it becomes non-blocking. In the old version of this, if a device was offline, none of the code afterwards would run. So effectively, one device would kill the entire system. Now it becomes non-blocking. So it tests if that device is online. Then says, yeah, that client is online. And then it tests the second device and it goes, great, that client is online. So there's two current online clients, A and B. So after it's tested what devices are online, it's got a new array of online devices. So it doesn't just trust that, oh yeah, this is definitely right. It goes through this list and goes, which ones of these are actually on? When it knows which ones are actually online, it will then send out one at a time. So go to the first one and says to it, here's a second request. How many options do you have? So in this case, it's one. And it replies going, I've got one option. And then it says, great, give me option one. And then it requests that one option, and then it will send that option back. If it was to have 5 options, it'd go, great, send me option 1, and then it waits for the confirmation of that. Cool. Send me option 2, waits for the confirmation of that. Cool. Option 3, option 4, option 5, and it does them as one request at a time. Again, this is to stop breaking changes, and it means that if at some point the communication drops, maybe that option doesn't load, but it will then continue. If it then reestablishes, it will then continue and load all of the other options. And it does like retries in there to try and make sure that it definitely gets all of the stuff that is available. So long as the ESP-NOW connections don't break, it really should pull everything that it needs. And it adds all of those to its own internal options list. Then when it's completed all of the options from the first device, it moves on to the next device and does the same thing. It says to it, how many options do you have? Which again, in this case is 1, but then it comes back and it asks for those options one at a time and adds them to the array. This is where the unique ID stuff comes into play, because what happens is every time a request is made from a server to a client, it generates a new unique ID and attaches that unique ID to the request. So when it's doing the awake request, we'll see if we go to the top here, it goes generated unique ID 3098. Then it adds that to a request list. So it's created a unique ID and it's added that to a list. It's basically just an array that can expand and and shrink as it needs to. Then it sends that request with that ID off to the first device. And that device then goes, okay, I've got this awake request and it's got this ID attached to it. I'm going to respond to say, yeah, that's cool. And when it responds and attaches that unique ID that it's just received to the response. So then when it's in the background and the server is checking whether or not it has responded, when a response comes in, it sees that unique ID attached to the response and it knows which request that it originally sent out that response is in response to. So it means that if we were to hypothetically send a request out to 5 different devices at once and we tried to multi-thread it as opposed to doing it one thing at a time, we can then listen and know which things have replied because the IDs of the requests match with the response. And when a response comes back and it's got that unique ID, we remove it from the request list. So here 3098 is removed from the request list because it correctly responded. What it means is that we end up with this list, and if at any point there are items in that list, that means something has failed, a response hasn't happened, and it means we can then zero in on at what point it failed. It's really just a debugging and administrative thing that you may or may not ever need to use, but what it does mean is that if you do want to keep track of any errors that are happening, we've got a list of literally all of the failed responses. The second thing that the unique ID does is when it's requesting the options, so the third byte, it's tested if it's awake, it's asked it how many options it's got, and then it's requesting the options one at a time. When it goes and requests the option, it has a unique ID attached to that. So we come down to here, there we go, we got one option to get. So we're requesting one option from the first device. And we have the unique ID that's just been generated for that request, which is 3401. And that's added to the list. Then when that request is sent to the client goes, okay, this is an option request type with the unique ID 3401. What I'm going to do is internally, I'm going to store 3401 as that unique ID against that option. And then as it requests all the other options and they come in with the unique IDs, it associates those new unique IDs with those options. So each client at its time of startup has new unique IDs every time that associate to each one of its items. The server also shares that unique ID and stores them in the menu options. So we end up with a bunch of different clients which have all got unique IDs on all of their options, and the server which has got all of its internal array of all of the different options across all of them with that unique ID. Which means when I change something, let's say I change a button, what I have opted to do is broadcast that change request to every device. So when I click a button on or off, it sends that to all of the devices at once. And then all of the devices check if they have that unique ID, that option in their list. If they do, they change it and they respond to say, yes, I've made that change. If they don't have it, they ignore it. The reason I did that is because in the future, there might be a case where device A needs to know about something device B is doing. So they would want to be able to, see the status of things between one another. It's not something that I've thought about actually implementing yet, but it's kind of like a future proof and something that we may implement on going forwards. But that's why it does it that way, and that's why all these unique IDs get thrown around all the time, is because it's using those numbers for everything. It also means that we don't get issues with when we're building a UI. We don't have to worry about the index or anything, because in the old version we were passing through the index of the menu item. Now you can imagine what if we'd created a menu and then each device had its own sub-page. The indexes would be kind of really hard to start managing in between that, but this way we just attach a unique ID to each UI element, and so long as it knows which unique ID it's being sent back, that's how it works. So when we look in the server code here, this is the button press, which does the set value. It is looking at the menu items. So in the server, I have this menu items array where I have this full list of all the things in the menu items. And this one is currently using the index just because of the way that it works, looping through one item at a time, because it's a very crude UI, and in the future this will be changed. But then it will take their set value. So set value will pass it the unique ID of that menu item and the new value. And then all of the checks and stuff will go on behind the back. So that's how that all works. And that's also why if a device reboots for some reason, the server no longer knows about it, because it's rebooted, and when a device reboots, all the unique IDs are set to 0, and the server is obviously sending out these things for a unique ID based on the UI that it has built. And if a device is restarted, then it doesn't know about that. There's maybe a debate to make it a bit more persistent, but for now it's fine, and it just means that a device reboots and it's not working. Just rebooting the server should be able to pull them all back in. It's also why that function exists that I mentioned earlier, which is the restart devices, because we can force a reboot of the server from the phone or from the UI or whatever to re-pull in all of the options. So outside of that, all of this is pretty simple. A lot of it is just initializing the options that we want into the right structures for ESP-NOW and making sure those communications back and forth happen, and then just attaching unique IDs to those communications and handling the lists. Like I said, one of the big things that I changed was I got rid of using EEPROM. I just found that it was not versatile enough, and it's actually officially depreciated for use on ESP32s. So I went through just looking at a few of the other options like preferences and NVS, Tried them out and found actually NVS, so basically just going straight into the non-volatile storage, was working out the best, and it was working the easiest. So there are some functions in here that automatically handle all of the NVS storage on the clients. So it's just store memory and get memory. Again, it's dead easy. It just uses these index values, and the indexes are just based on that options list, and it just sets the value or gets the value from the memory. And then we've got our various requests. These are very similar to the stuff that you might have seen before. So just works with the different types. So we've got like a request awake. So it just sends a response back to the server saying, with the unique ID, saying, yes, I am online. Request count just replies the number of options. Request an option sends an option based on the send option unique ID, based on the unique ID, and set value. So it'll try to update the value, and if it does update the value, then it sends a request back to say, yes, that value is updated. That's another thing that's like the UI for the server is never like set and forget. It doesn't just send a new value off to the client and go, yeah, that's cool. What it does, it says, try updating this value, and then it waits. Like if a switch type, you like turn the switch off, it doesn't actually just turn the UI for the switch off. It'll wait and go, has anybody successfully done that? When they reply going, yeah, I've done that, it goes, great. Then it updates the UI. So it's all, you can trust that if your server UI is showing that a change to an element has happened, it has actually happened, because it does it only on response, well, a positive response, as opposed to just assuming that it's happened correctly. Just check that there's nothing in the server that I think is worth pointing out. I don't think there is. Like I say, it's all pretty simple. You know, we've got these functions that test awake. We've got a registration of all the peers. Reset clients is the one, like I say, it'll just clear the list and then re-register all the clients. Set value. Yeah, I mean, these will change over time. But hopefully I can update them using non-breaking changes, so that, you know, if you are deciding to, you know, build this around a device that you have created, it's not going to kill it. But I can't promise that will always be the case. There will probably be some things that are breaking changes, but, you know, alpha stage. And then, like I say, we've got this control list. So this start timeout basically runs, and our default timeout is... default timeout can be passed into it, but I believe we've set a request timeout as 2 seconds in the H file for the server, so you could change that if you wanted to have it wait longer. But ESP-NOW is very, very quick, and it's supposed to work up to like 220 meters away, which should be more than sufficient for most cars, I would think. You could probably use it on a train and it would be fine. Obviously, I've not tested it for that distance, but yeah. I think that's basically everything. You know, we've got like this list management, handle requests, add options, just basically, you know, adding things to arrays, moving things from arrays, handling callback functions. And all the code is on here, like I say. So if you did want to come in and take a look at like the client code that makes it run, you can go and check it out. Also, like I say, there are an example. So there's an example client, which is very similar to the one we've just done, but it's just got 2 buttons based on the spoiler light I was building before, and then it's got like 2 options, oh no, 3 options: DRL, break, and glow. And you can, you know, turn any of these on and off with the server, and you can see then how they affect it. But this is an example of how you might set it up, and you know, this is the test in here to see whether or not the server has allowed it. And then again, there is an example of a server within here. It's just the single line option that works on the serial print that I've been showing you in this demo. This will change very, very significantly in the coming week or 2, and hopefully I'll get a cursory UI available very soon. I'm quite looking forward to getting back into a little bit of React. I used to be a very senior React developer, but I haven't touched it in probably 4 or 5 years. So it's going to be interesting to see how much it's changed. But Yeah, so we'll create some UIs that look cool and people want to use. So hopefully that's helped you see that this system is actually pretty good, I think. Pretty robust, and it handles everything. Be interesting to hear if you think it's got application outside of other protocols which do similar things, like I said, like MQTT, and there is potentially an opportunity for, like I say, again, for me to try and implement something like MQTT into this and have it so that you can initialize a server and have it use the MQTT protocols for the communication bit instead of using ESP-NOW, but the setup is maybe done through ESP-NOW to get all of the values from the client and initialize the server properly. I don't know. It's a TBC, and I've got a whole rabbit hole to dive into, but that's it for now on this one. And please go take a look at it, try it out. Let me know if something breaks, because I haven't tested a lot of stuff on it, and I will keep you updated over the coming weeks when we start releasing UIs and stuff. But obviously, if you do just monitor the changes on the GitHub, you'll know when things start to go up. That's the easiest way to get notifications. And like I say, the link is in the description if you wanted to check it out. I obviously have a lot of work to do on this, so I'm going to get going on that and start playing with it a bit more. If you do want to keep up to date with what I do increasing this in the future, make sure you hit subscribe, because I will be updating all that stuff and making loads of cool projects that integrate into this that you can use in your car. We've got tons and tons of ideas that people have been sending me, so I'm going to start implementing some of these and have them all work together, which is going to be dope. And if you do enjoy seeing this kind of stuff, feel free to give it a little thumbs up so I know about it. Whatever you do with the rest of your day, have an absolutely wicked one, and I will see you in the next video. Take it easy, people. Bye bye.